So welcome in another video. After the gel coat we have applied, you could think that I will cut all my layers of carbon, fiberglass and start to prepare some epoxy and we'll stack all together on the mold. And okay, no guys, don't do such thing. You absolutely need to know two fundamental rules, because else if your mold will twist, warp or something like this, or you're gonna have some print through. The first question you have is, I have a mold, there is a surface, so this one is approximately 0.5 square meters, and of course you will purchase by your carbon accordingly to the surface. So I will show you right now the carbon I have bought. I bought a 167 grams, which is a twill 2x2, which means that, okay, it looks like this. It's very used in the motorbike, racing car industry, so on, because for bonnets and so on, because it's nice. So 2x2 twill means that we have fiber in the 0-degree axis and 90 axis. Very important for the following part of the video. The second one is a bi-diagonal, non-woven 300 carbon, and bi-diagonal are more known as bi-axial. And I have decided also to put some core. It will be sandwich composite mold. It looks like this, so you can see probably the hexagon that are printed through. So why? Because this hexagon help to follow the mold, the wing, and also because through the hexagon, from the top to the bottom, the resin can flow. And so, because later I will explain which type of process we will use. So it exists in different height. This is 3 mm.3, and this one is 10 mm. So of course it's less flexible. So the first one is very nice when you have high curvature. Now the first rule, there are two rules. The first rule is you want a balance of the mold. You want no tension in the mold. For example, if it's summer, you are maybe transporting the mold, give him to a friend, and it's more than 50 Celsius degrees in the car, and then your mold is wrapping. This idea is about that in a material like a brick, it's like unidimensional. The atoms are everywhere. But in composite it's not the case. So look, you have some fiber here in the 0 degree. You have some fiber in the 90 degree, and of course you have in 180 degree and 270 degree, of course. And this is our famous 167 twill 2x2. This is what he's doing, this guy. And we also have a 300, which is a bi-diagonal. And this guy is working like this, plus 45 degree, and also here. So he's also working in the opposite direction. So now you start to guess what we want. We want to have some fiber in every direction, and we want to have the same amount of fiber in every direction. Because if I put, let's say, 3 kilograms of fiber in the 190 degrees, 3 kilograms, and only 100 grams in the 270 and 90 degrees, guess what happened? The mold will twist. We have to balance And this is why you need to think about buying your product, your parts, your carbon. You need to think before. I will not do the calculation in detail of what I have bought and what happens, but simply I can make 12 layers of 10760 and 6 layers of 300. So let's do the math, and it's 1800 grams in the minus plus 40 degrees, and of course the opposite direction, and this is approximately 2000 approximately grams plus 0, 90 degrees, and the opposite direction. So what do you think? So this is almost balanced. There is little difference of 10%. It's almost nothing. So that was the first principle, balanced. So we say, now we're waiting for the second rule. And the second rule is symmetrical. Symmetrical. So, for example, you will not stack all your 300s against the gel coat, 6 layers, and all the 12s 10760 on the top. This is not symmetrical, not at all. No. And remember, we have two core. The core is this thing. This is the white thing. This is the core. So we have to share the layers of carbon between the two cores. So two cores, it's like this, which means that you will have how many? We will have 3 layers of carbon. Multiple layers, excuse me. Here. So now the question is, how I do this? Okay, let's remind that we have 12 of 165 and 6 of 300. Guess what? We will have 4 and 2. 4 and 2 and 4 and 2. Easy at this moment. But we have not exactly explained the detail of this multiple layer, composite of 4 layers of 167 and 2 layers of 300. Let's explain. I will put 1 300, 2 167, 1 300 and 2 167. This will compose each multiple layer. Okay. So I will have this against the gel coat, and after I will have the core, which is a foam. This foam is the heaviest one I have found on the market for a guy like me, a hobbyist, and the foam is 110 kilos per cubic meter. It's important to tell you this, so you figure out what happens. So I have to simply put the same in the middle of the two core and the same on the top of the mold, the composite mold. Symmetrical. Now you will have a question. You will think that's strange because you are putting a 300 grams directly on the gel coat. Normally you will put light fiberglass or carbon. And this is because this is non-woven material and it will let less print through. I mean that the fiber are like this and not crossing each other. You have multiple layers that are stacked above each other because the 167, the twill 2 by 2, it means that there are two crossing on two on this side. Okay, two here and two here. So it's making like this all time. This type of material, woven, are letting more print on your material than a non-woven, I cannot, the 300 is a non-woven. Diagonal, bi-axial. Then this is why I will stack the 300 grams. The first one, the first layer, will be stacked directly on the gel coat. So now I want to come around some special things I want to do on this mold. This is a prototype and this mold will sustain a lot of compression because the elevator will be molded with carbon and with a core. This core is also a foam, not the same foam than I use for the mold. And most of the time people are using the EFG31 kilogram per cubic meters. It rarely weighs 31 kilo per cubic meter, generally more. So we have to compress the two faces of the mold, intrader mold against extrader mold, and between you have your core and layers of carbon. Yeah, that's good. But how to do the mold and how to reinforce the mold? This prototype will try to include some reinforcement as much as possible inside the mold. So I will explain you a little more. If we look the mold from the above, it looks like this. You have your elevators or your wing, whatever you want. It looks like this approximately. And you have your mold like this. It's rectangular, it's like a box. As you can guess, the problem will come around here. To maintain the profile here in this area, in the curvature. Okay, in the curvature, that's the problem, to maintain the exact dimension and accuracy of the curvature. Because if you press too much here, what happens? Your profile will bend like this. Maybe you will break the mold. Yes, could happen, 100%. And so your profile is not accurate anymore. That is one of the problems you have when you are making some compression. You remember that I have this white thing like this, and the idea is to cut it here. So you will have piece 1 here, piece 2 you cut here like this, piece 3, 4, 5 and 6. So what will happen is, if we look here about this core, you have two core. You will have, so one cut here, 2, 3, 4, 5, 5, yes, 5, here we are. And now what I will do, I will make some spar with some carbon here and here and here and here and here, and again the second core here and here and here and here. I will have some carbon left. I will use little pieces of this to reinforce my mold. So normally a spar, how it works. A spar is working, sustaining some compressive force directly from the height, and also you have to reinforce it plus minus 45 degrees. So normally I should use this type of carbon unidirectional. The fiber are going to one sense. You have some fiberglass, but it's just to maintain the different carbon, I don't know, this type of. But I cannot use this one. First, it's only 10 centimeters, so I will have to make a lot of work. And secondly, it will not wrap around the corner, because it's 90 degrees corner. So it will not work, it will be a pain in the ass to do the job. So I will use the 300 plus minus 45. So that's the solution I have found to reinforce the mold directly. Of course, it doesn't prevent you to later to put some additional reinforcement on the top. That's what I will probably do, because of course you have to clamp the mold. So there are two solutions. So you can screw it or you can clamp it. Use some clamp. And you want to avoid excessive forces, compression in a small area as much as possible. Next video we will see rapidly, not all the process, but what it looks like after cutting the carbon and stacking the layer on the mold directly, because we will use a non-standard process to make the mold, which is rarely used in the hobby industry. So I will show you this in the next video.